back again. Okay, do you had class just now, 11 to 12? Any other subject?
No.
You have class, is it? Oh, you are free, eh? Okay, then. Okay, so class, let's be continue. Let me share the screen. Okay, class. So yeah. So let's continue from what we left just now. So what we learned so far, we learned about what is amplitude, frequency, wavelength. Then we talk about phase difference. What is progressive wave? A type of wave that transfers energy to the direction of propagation. Okay, phase difference is what is phase difference? It's a fraction of cycle when one wave moves behind the other. Okay, so yeah. Okay, let's do some questions first. Okay, what is the answer for this question? Which graph is correctly labeled? You have two type of graph, distance versus distance is displacement, and distance is time. Okay, two type of graph. So which is correctly labeled? So A is wrong because of what? Cannot be period. Because it's the distance, so it should be wavelength. Cannot be period. So A wrong. B, what's the problem? B, amplitude is wrong. Amplitude must be from equilibrium to the top. C, mistake is the wavelength, because x-axis is time, but it should be period, not wavelength. So D is the correct one. Time, period, and this is your amplitude. Okay. So D is the answer. Okay, 24. What is the name given to the number of compilation particle in 1 second? Number of oscillation particle in 1 second? Of course, it's frequency. No doubt about that. Easy question. 27. What are the amplitude and frequencies? So amplitude is the maximum, which is 5 mm. Frequency is how much? Of course, 20 milliseconds. So 1 over 20 milliseconds. 20 milliseconds change a second. So 1 over 0.02. So I think you get a 50 hertz. So 50 hertz. So 5 millimeter and 50 hertz should be the answer for the B. Okay, so these all are straightforward questions. Okay, we move on. This question is challenging one. Okay. Hey, guys. 1 minute for you. Give me the answer. What's the answer for this? Okay, which statement about the motion of the point in the string is correct? The speed at point P is a maximum. Is it true? The speed at point P, is it a maximum? A is wrong, right? Speed at point P is the minimum, 0. Make a turning. So A is wrong. B, the displacement at point Q is always 0. Is it the particle Q will be always displacement 0? No, right? The Q is going to move up and downward. So the displacement of Q is not always 0. It's going to change up and down. We're going to oscillate up and down. So B also wrong. It doesn't make sense. C, is it correct? The energy at point R is entirely kinetic. It should be entirely potential, right?
Yes.
It should be entirely potential. So C is wrong. At R lowest point and the peak point, it should be entirely potential. Only at the middle is entirely kinetic. So C is wrong. So D is answer. The acceleration point S is a maximum. I already told you the reason. Why? Because make a turning. And something make a turning, it experiences the greatest changes in velocity. Therefore, D is the answer. Okay, so no questions, can understand. Okay. Get me the answer for this. What is the phase difference between X and Y? What is phase difference means? It's a fraction of a cycle where one point moves behind the other. It's a fraction of a cycle. X to Y. What is the fraction of a cycle? How many cycle it is, X to Y?
One and a half
cycle. Yes, X to Y is 1.5 cycle. So there is a 1.5 cycle. They are 1.5 cycle. So one cycle, how many radian? 2 pi radian. So 1.5 cycle, how many radian? 3 pi radian. Okay. So the phase difference between X and Y is 3 pi radian. So therefore N equals to what? N is 3. N should be 3 because it's 3 pi radian, because it's 1.5 cycle. From here to here is 1 cycle. From here to is half cycle. So 1.5 cycle is same as 3 pi radian. One full cycle is 2 pi. So N is 3. N is 3. Any problem here in this question? No problem. Okay, good. So X to Y phase difference is 3 pi radian. So N is 3. Okay, this question. What is the phase difference between X and Y? So X to phi, what fraction of a cycle it is? X to Y.
135.
135. X to here is half cycle, right? Here to here is half cycle. Then here another quarter cycle, right?
Yes.
All together, how many cycle? 3/4 cycle. 3/4 cycle, right? 3/4 cycle. Sorry. So one cycle, how much the radian?
Pi.
One cycle is pi, or in degrees?
180.
So one cycle, 180. So one cycle is 360. So 3/4 cycle must be how much? 270, right? 270 degrees. 3/4 cycle. So answer must be D. D. Or what is another phase difference could be? It should be 270 or another one. Let's say put it in a circle as I told you. The X, let's say X is here means Y is here. Y is here on top here. If X here means Y is on top here. Okay, we found that the phase difference is given is 270. That's the choice given in the solution. Okay, 270. Or which one can be the phase difference?
90.
What is another phase difference? 90. Yes. So it could be 90. Can be 90. Could be 90 or can be 270. Okay. So if objective check is it 90 or 270 available? Can be 90, can be 270. Okay, good. There's a phase difference. Okay. Okay, so that's about phase difference. Okay, transverse and longitudinal wave. Not much to say about it. What is transverse wave? The oscillation of the wave particle is perpendicular or parallel? Perpendicular to the propagation of the wave. What you learned last time. Recall back. So transverse wave, the vibration of the particle of a wave is always perpendicular. One mark of a vibration, perpendicular another one mark to the propagation of the wave. Okay. So the EM spectrum water is a type of transverse wave. So this is how the transverse wave should look like. The particles are moving perpendicular. They are oscillating up, but the wave is moving forward. It's perpendicular. So transverse wave. Okay, longitudinal wave, they are moved parallel or along the same direction. The wave, the propagation of the wave. Okay. In Cambridge mark schema, instead of they put propagation of the wave, they say the direction of the propagation of the energy. They give mark scheme more to energy, the direction of propagation of energy. I think you can replace the last part, the direction of the propagation of wave. Instead of right direction of propagation of wave, you say direction of the transmission of energy. Okay. Cambridge emphasizing energy more. So of course, a longitudinal wave is the sound wave, and cannot be the water wave. Sound wave and seismic wave. Seismic wave, the wave during earthquake. Okay, during earthquake, how the land is shaking. Seismic wave. Seismic wave is also another type of longitudinal wave. Seismic wave. Okay, seismic wave. Okay, during earthquake, it's a longitudinal wave. Okay, so this is how the longitudinal wave moves. The particles are move parallel to the propagation of the wave. They also oscillate parallel to the movement of the oscillation of the wave. Longitudinal wave. Okay, so of course we have bottom trough, up is crest. For this is a transverse wave production. For a longitudinal wave, you have compression, you have a region of compression, you have region of extension. We call it rarefaction. Compression, rarefaction. Okay, compression, they are highly pressurized. Rarefaction, they have what you call they extended. The particle at compression and rarefaction, they unable to oscillate at all. The oscillation is zero at that moment. So compression and rarefaction. Okay, tell me, compression to rarefaction one wavelength or compression to the following compression one wavelength? Your O-level knowledge, your SPM knowledge. Compression to compression one wavelength or compression to rarefaction one wavelength?
Compression to compression.
Very good. Compression to compression is one wavelength. Rarefaction to rarefaction also one wavelength. Okay, yeah. So yeah, that's the one. Compression to another compression is considered as one wavelength. Okay. If a graph is given like this, up and down, this graph not only represents a transverse wave, this graph also represents for longitudinal wave. So in exam, very frequently they ask, they'll show the graph like this. The graph is displacement versus distance. They will ask, is this wave, is it a transverse wave or longitudinal wave? It could be transverse, it could be longitudinal. Longitudinal also we have to draw like this, because of course it displays horizontally, but in the graph, the displacement axis is vertical. So we have to show vertically up and down. Okay. So if in the graph displacement distance is going up and down, this could be longitudinal or transverse wave. Okay. So compression to compression is one wavelength. Okay. This is about pressure difference. Normally, compression will have high pressure. Okay, rarefaction has a very low pressure. Compression to compression. Okay, so the compression will have a high pressure and rarefaction will have a low pressure. At the low pressure and low pressure, still they are unable to oscillate temporarily. Okay, so compression, high pressure is the compression in a pressure form line. Pressure form. Compression leads to the high pressure. Compression always high pressure. Okay, now can you describe the motion of the particle at the moment of a transverse wave? Okay, there are 4 particles selected, O, P, Q, R. Let's say you are standing here, like you are the particle on the water wave. Water wave is moving to the, let's say to the right, moving to the right. What is the subsequent movement of the O? Where do you will be moving when the wave is traveling to the right? You are not moving to the left or right. You are only oscillating up and down. The moment the wave is moving to the right, you'll be moving up or moving down. The O will be moving up or down. P is it will moving up or down. So what will happen to the Q and R? Which direction they'll be moving? So that's this slide. Can you describe the motion of the particle? Is the particle going to move up or down? Anyone? Where the O will move when the wave move to the left, to the right, sorry. So how to find that? So first, move the given wave profile slightly to the direction of the wave propagation. So draw to find out where they're going to move. Are they going to move up or down after a short while? You draw a wave profile slightly to the direction of the wave propagation, because this is the wave profile. The wave profile is moving to the right. So draw a wave profile. Draw arrow from the point given in the news. So this is the, you see, this is the new wave profile. Let me rub this. Okay, you see, draw a wave profile. This is the new wave profile. This is the new wave profile because the wave profile is moving to the right. Now you can see where the O going to move. The O going to move upwards. They're going to fall to the new wave profile. The O is on the way going upwards. Where's the P going to move? P going to move down. You're going to fall back downwards. Where's the Q going to move? Q is going to move down. Where's the R going to move? R going to move up. I think the entire particle from here to here, it's going to move up. All of them are moving up. Okay. The entire particle from here to here, they are moving, all of them moving down. And the same thing, entire particle here are moving up. So they're going to fall back to the new wave profile, Okay. So if the question asks where the particle move, the consequent movement, you have to draw the new wave profile. Check the wave moving to the right or left. If it's moving to the right, the wave profile, the pattern, you have to shift to the right. If the wave is moving to the left, you must change the wave profile to the left. Then you can see where the particle going to move. Is it up or down? The particle never move left or right. They only move up and down. Okay. So get me the answer for this. Use the technique I to show you. What is the answer for this? Where the particle P and Q will move. What is the consequence movement of the particle P and Q? The wave is moving to the right. So do the method I show you. Draw the wave profile, a new wave profile, shift to the right. Okay, draw the wave profile, shift to the right. Okay, so show the wave profile, shift to the right. So what do you do? Here the pattern. You draw the wave profile, shift to the right. A little shift to the right. Because the wave is moving to the right, because it's moving to the right. So where the P is going to move? Up or down? P going to fall? Down. P is moving downwards. P is moving downwards. Where the Q going to move? Q also going to move down. Both of them going to move down. Okay. So then what's the answer? So what's the answer? A, B, C, D. Which is the answer? So P is moving downwards. Q, we don't have downwards, but they put stationary. Yeah, so Q could be stationary at that moment, just for a while at the top. Okay, at the top, it could be stationary for a while, just for a while. So the best answer we can go is, which answer? A. So A is the answer. P is going down, Q is going up. Okay, so you draw a new wave profile to the direction of the wave traveling. If it's traveling to the right, change the wave profile to the right. Then write all the particles where they are moving. Okay. So that's the answer should be. Should be A, downwards and stationary. Okay. Okay. What's the answer for this? Anyone? The graph shows how the displacement of particle in wave varies with time. Which statement is correct? What's the answer? The wave has amplitude 2 centimeter. Yes, it has amplitude of 2 centimeter. It could be transverse, or it must be transverse, or it must be transverse or longitudinal.
Oh,
Is it transverse or longitudinal? Or it could be transverse and longitudinal.
A.
Yeah, it could be both. It could be both.
So,
By
yeah.
referring to the displacement as the time graph, it could be transverse, it could be longitudinal. Yes, any question? Can, So the answer should be A. 2 centimeter, but it could be either transverse or longitudinal.
Sir.
Yeah.
What if it is a displacement distance graph?
Same. Displacement distance graph also, the displacement they show, the displacement the graph shows, here the axis we put it vertical. We don't know that this displacement in a reality in the particle, is it horizontal or vertical? Is it horizontally displacing or vertically displacement? We're not sure. We can't identify from the graph. Okay, so for the displacement the distance also, it could be transverse or longitudinal.
Okay.
Okay. Okay, so that's about the phase difference and the particle. Okay, now we go into something new called intensity of wave. Okay, about today's lesson, the remaining time, I think we're going to spend time here. Okay, you heard of intensity of wave. The practical name for intensity is what? For a light, I think brightness. Brightness, a technical name is intensity. Brightness. How bright is the light? How intense is the light? Okay. The progressive wave transfers energy from the source. Okay. This is what they found. They found that the wave amplitude and frequency linked to the intensity, how bright it is. How bright is the wave? Or for example, I focus with the light wave. How bright is the light wave is depend to the amplitude and frequency. So science found so far, the intensity is found to be directly proportional to the amplitude square and frequency square. Okay. How they got this formula, you will get to know in A2. Okay. For AS, you need to accept this. The intensity is directly proportional to the amplitude square and frequency square. Greater the amplitude, greater the intensity. More intense the light. Greater the frequency, they say greater the intensity also. Okay. But in your syllabus, in your A-level syllabus, they never show the frequency. They just say intensity is directly proportional to the amplitude square only. Okay. So amplitude square only. So now you check here before we go to the question, and I'll check here. So I proportional to A squared. This is what we're going to adapt now. Okay. Frequency, we leave it for a while. Not much asked. Your syllabus is only I proportional to A squared. Okay. I proportional to A squared. Let's say you have a wave. With amplitude A, intensity is I. Okay, intensity is I. When the amplitude become 2A, if the amplitude become 2A, what is the new intensity? How many I? How many I?
Oh,
Use this proportionality.
4i.
4I. So it should be 4I. So it's square lah, A squared one. So if the amplitude is 3A, then the intensity is going to be 9I. 9I, that's a link. Okay. So from this proportional, we can say that I1 over A1 squared must be equals to I2 over A2 squared. That is the formula we adopt. Okay. So I1 over A1 squared must be same as I2 over A2 squared if you proportional. Okay. So one question. Use the relation I proportional to A squared. What's the answer for this? Intensity is directly proportional to A square. X is 3 box, Y is 1 box. What is the ratio of intensity X to Y? So you can WhatsApp me answer. I proportional to A square. Yes, good. Okay, so very fast. Eh? So if you understand the proportionality, your maths is good, then you know it should be A. If you got A, eh? So I of X is proportional to 1 squared. I go for 1 box, 1 squared. I of Y is proportional to 3 box. Sorry, X is 3 box. Eh? So 3 squared. Y is 1 box. I put 1 squared. Okay. So yeah, of course, Ix over Iy. So it's same as 3 squared over 1 squared. 1 squared. Of course, when you make it equal, you have a constant k, but the k will cancel. We don't need to find the k, cancel. So you get 9 over 1. So 9 over 1. So you get a 1a. Okay. Okay, so this is intensity. Okay, so this can be another working. I1 over A1 squared equals to I2 over A2 squared. Let me clear this. So I proportional to A squared, I1 over A1 squared equals to I2 over A2 squared. So you rearrange Ix over Iy is 8ax squared over Ay squared. So you get 9. Okay. Okay, now more laws applicable. Just inverse square law. So the intensity I of a wave is rate of which energy is transferred by the per unit surface area perpendicular to the direction. Okay, this is the original formula for intensity. If I want to go for top one, the power over area. You look at this diagram. Look at this diagram. The source, let's say, has a power of P. Okay. When it move away a distance of R, you see the light going to spread more. The light going to spread more. When it spreads more, the brightness drops. That means intensity drops. Why intensity drops? Because the power of a light has been distributed in a greater area. In a greater area. The area they use here is the area of a what shape? The area of a sphere. It's going to be area of a sphere. Let's say you have a light bulb here. It's 25 watt. Okay, 25 watt. Let's say you stand away here about 1 meter away. Okay, the 25 watt of power has been distributed in a sphere. It's spreaded in a sphere. So what is the intensity you receive here? What is the intensity you receive here is actually the power of the source, which is in this case 25 divided by the area it spreads. What area it spreads? The area it spreads is a sphere. What is the formula for a sphere? The area of a sphere. The area of a sphere is, what is the formula? 4 pi r squared, right? The area of a sphere. 4 pi r squared, right? So 4 pi r squared. The r is 1 meter. So this is the original intensity formula, power over area. Okay. So because power is P, the area will be a area of a sphere. So that's why it's going to be 4 pi r squared. 4 pi r squared. Okay. So here, this is called inverse square law. Inverse square law. Why inverse square law? The intensity is directly proportional to the, inversely proportional to the square of the distance. That's why it's called inverse square law. Okay. What is the unit for intensity now? Now you know the unit for intensity. Power, what unit? Watt. Area is per meter square. This is the intensity unit. Watt per meter square. Okay. Last time we said how bright is a light. Brightness of light is in terms of watt per meter square. How many watts spreads per meter square? Okay. So this is another new formula about intensity. We found that intensity is proportional to amplitude square, the earlier slide. And now we found that intensity is P over A and intensity is found to be proportional to 1 over r squared. 1 over r squared, something new lah, something new. Okay, more further distance the light spreads, more bigger the r, more smaller the intensity. Okay, more bigger the amplitude or more bigger the intensity. Okay, so you have two formulas lah, two formulas. Okay, any questions from here? Okay, I think you can understand more by going through the questions. Okay, so I is proportional to, let me rub this. So I is proportional to 1 over r squared. Okay, it's 1 over r squared. This is called inverse square law. So let me test this to you. I proportional to 1 over r squared. Okay. So let's say I tell you. Okay. Let's say you have a wave as about distance of r away, the intensity is found to be I. Okay, the wave traveling. The wave 3r away, what is the intensity at this point? How many I? How many I? So how do you find this? So I proportional to 1 over r squared. That's the link you have to use for this. You don't need to use amplitude here because here distance matter. So I1 R1 squared must be equals to I2 R2 squared. Yeah, this is how you write. So this is 1 lah. This R1 I1. So I R squared must be equals to the new intensity we are looking for. We just put x. The one you're looking for, put x. R2 squared. R2 how much? Is 3r squared. Okay, 3r squared. Here, common mistake students do is they only square the r. They have to square the 3 also. 3r squared. So it becomes 9r squared. So what is x? X is I over r squared over 3r squared. 3r squared. So you get what? How much? You get 1 over 9i. Yeah. So the intensity here is dropped by 1/9 of the intensity here. 9 times smaller intensity when you travel, when you move a distance of 3r. So this is how the working should be based on this relation. Okay. So yes, but when the wave travel, and the wave started a big amplitude, when it travel, the amplitude will get smaller and smaller. Okay. So I proportional to what? Amplitude square, and intensity proportional to what? 1 over r squared. Okay. Sometimes the question will ask linking these two. Linking what? Amplitude and r. Sometimes they can ask question. So how amplitude and r related? This is the relation. So amplitude square is proportional to 1 over r squared. Okay, you can use this link. For example, I use one question to this linking. Let me try again. Okay, I said from the source. Okay, about 1 meter away, the amplitude is found to be 5 mm. The amplitude of the wave found to be 5 mm. If the wave travel 5 meter away, what is the new amplitude here? What is the new amplitude here? Okay. So this is comparison within what and what? R and amplitude. So intensity proportional to amplitude squared, proportional to 1 over r squared. But this question is about amplitude and distance. So you don't need to use I lah. So you just use this relation. Okay. So a squared proportional to 1 over r squared. Or in other words, this we can simplify to a proportional to 1 over r. Okay. So a1 r1 is equals to a2 r2. Yes, good. So you can get the answer already. A1 is what? The first set of reading lah. This one. So A1 is 5. R is what? R is 1 mm. No need to change unit. Okay, because going to cancel. A2 is the one looking for X. R is 5. R is 5. So finally you get what? You get X as 1 mm. So here the amplitude going to be only 1 mm. Okay. The wave getting smaller and smaller, here found to be 5 mm after travel 1 meter away. When it travel 5 meter away, okay, the wavelength amplitude will drop even smaller, and it should be found to be 1 mm after travel 5 meter. So this is the relation you have to use. Any questions so far?
Teacher.
Yeah.
What about the frequency square?
Okay, frequency square, not in your syllabus, but only 1 year they came out frequency square. Okay, let's say frequency square given. Let me give you one question. For example, they said, okay, the wave, a wave has an amplitude A and the frequency F. Another amplitude as 2A and frequency 3F. This intensity is I. This intensity is how many I? This intensity is how many I? For this case, I proportional to amplitude square, frequency square. Use this link law. Okay. So for the first one, intensity is found to be what? Intensity is found to be, for the first one, intensity is of course. So I A1 F1 squared. So I proportional to, yeah. So I over A squared F squared, all 1 1, must be equals to I2 A2 squared F2 squared, like that. Okay, put all the key in all the values. So first set is what? I AF whole square. Okay, the second one, the one I we are looking for, so we put X. This one is what? 2A, so 2A squared. And F is what? 3F squared. Okay. So you can get the new intensity. Okay, so you get how much? I think you get this square, this square also. You get 12, so you get 12I. So the intensity going to rise by 12I. So you use this relation if A and F given. But I think the entire around 12 years of my experience seeing the question, only once came out. Only once came out with A and F, and they show this relation. It's already out of syllabus, but they show the relation to calculate. Normally, it's going to be amplitude only, amplitude square and R square, 1 over R square. Okay. Any questions? Can you understand? Can Okay, so we deal more intensity question now. Okay, let me go back. Okay, so one question, 1 minute for you. Read the question, figure out answer. So you have three choice. Are you going to use I equals to power over area, the original formula? Or are you going to use I proportional to A squared? Or are you going to use I proportional to 1 over R squared? Or are you going to use A squared proportional to R squared, 1 over R squared? What to be used here? The 1000 watts of radio station sends its power uniformly in all directions. Find the intensity of radio wave 10 kilometers from the antenna. So which formula do you use? 1, 2, 3, 4. Which relation? They say there is a radio station, kilowatt 1000 watts. They said about 10 kilometers away. They're asking what is the intensity here. This 10,000 watt, the 1000 watt has been spread into a area of a sphere. So what formula do you use to find the intensity? 1, 2, 3, 4. Power over area is the best. What is the power? 1000 watt. It's spread to what area? What area? What is the area of this sphere? 4 pi r square. So 1000 divided by 4 pi. R is what? 10 kilometer. So change to, of course, in meter. So 10,000 square. Will give you the intensity. Watt per meter square. This is the intensity. Okay. So when you read this question, you must figure out the first equation is most suitable. The other three is just to compare. When the amplitude is A, this is the intensity. When amplitude become 3A, what is the intensity? Like comparing two sets of reading, these three need to be used. If they give power and area, then you use the first one. So of course, the solution is power area. Okay, power area 4 pi r squared. So you get 7.96 10 to the power negative 7 watt per meter square. That's the intensity over there. Okay. Same like your Wi-Fi signal. Your Wi-Fi signal, your router in your house. The signal, when it transmits, I don't know how much of power, the router power you have. More router power you have means more range you can travel. The range can be longer. So yeah, so the intensity going to drop depend to this area. How much of area it covers. Greater the area it travels, greater the area it covers. So the intensity going to drop. Low intensity, less reception. Your Wi-Fi won't be that powerful. Okay, so do some exercise about intensity. First question. What's the answer? So which formula is? Intensity is power over area. The source is 30 watts. Spread it for a distance of 5 meters. So power over area. So 30 divided by 4 pi r squared. Why 4 pi r squared? Because the power going to distribute in all directions. So it makes a sphere. So you should get 0.095. Hope everyone got 0.095. So what's the answer? I equals to 30 divided by 4 pi r squared. 4 pi r squared. 4 pi r squared. Okay. So you should get this answer. 30 divided by 4 pi 50 squared. 5 squared, sorry. The answer. Okay, next. Okay, work out for me. So which formula do you use? Which come to your mind? I equals to P over A, I proportional to A squared, or I proportional to 1 over R squared, or A squared proportional to 1 over R squared. Which one to be used here? Anyone? You need to use 1, you need to use 2, you need to use 3 or 4. Which equation?
3.
3, yes, good. I with R, distance, yeah. Intensity of light 1 meter, 1.3 meter from the lamp is, yes, I with R. So the formula must come to your mind is just 3, this equation. Yeah. So I proportional to 1 over R squared. So I1 R1 squared equals to I2 R2 squared. Yes, correct. So to put the first set of reading, first I is how much? 1. R is how much? 1.3. The intensity is 1 when the R is 1.3 squared. The second intensity we don't know. So with the one we don't know, we put X. And the R is found to be 0.7. So you can find the X. So 1.3 squared over 0.7 squared. Give you the answer. Watt per meter squared. So anyone got the answer? So you should get 3.4 watt per meter squared. Okay. So the important is not the final answer. Important is out of these 4 equations on top, which one you feel is suitable. If you select the correct one, that means you learn the knowledge, how to be handling this. Okay, so all of you got 3.4. Okay, so this consider straightforward. Let's we move more questions. Intensity. Okay, now your turn. This is a little challenging one. Send me through WhatsApp your answer. Hope everyone got the same answer. Okay, 1 minute for you. Come on. So decide, are you going to use I proportional to sorry, what I'm doing. Is it I equals to P over A, or you're going to use I proportional to amplitude squared, or you want to use I proportional to 1 over R squared, or A squared proportional to 1 over R squared? Which one to use? 1, 2, 3, 4. Anyone? Which is suitable here?
Fourth.
Fourth, yes, good. So those who found the fourth one to be used, you are in the correct track. Yeah, this one to be used. Yes, this is the correct one to use. Those who are figuring out the first three, you can't use here. Because it's about amplitude with R. Can I work out the answer? Send me the answer through WhatsApp. Two sets of readings in. When a distance of R, the intensity, the distance of R, the amplitude is how much? When distance of R, the amplitude is 8. When distance is 2R, they're asking what is the amplitude. When distance is R, amplitude is 8 micrometer. When distance is 2R, they're asking what is the new amplitude. Okay, so this is the relation to be used. So anyone? Give me the answer. Okay, I receive answer. It's D. Oh, okay. Two of you giving me D. All of you got D? All giving D. So okay, everyone is giving D. Okay, I think so. Good news. Everyone getting the same answer. So A squared proportional to 1 over R squared. So we can simplify A proportional to 1 over R. So mathematically A1 R1 must be same as A2 R2 lah. So A1, this is A1 R1 lah. A1 is amplitude is 8, R1 is R, should be equals to A2 is we don't know, so we put X, and R2 is 2R. 2R. So yeah, X become 4. 4 same unit as 8. 8 what unit we use? We use 8 as micrometer, so this also should be micrometer. 4 micrometer. Good. The answer is D. So main thing, you should select this relation, A squared proportional to 1 over. Okay, good. So more questions. Okay, let's go to the next one. Okay, before we go to the Doppler effect, there's another one effect. Let me ask you more questions. Okay, go back to this paper. This is the past year. I choose the intensity question. Okay, I straight go to the challenging one. Okay, the challenging one, your seniors have come across difficulties. Yeah, 25. What year is this? This is yeah, page 7. Page 7, June 05. 25. Okay, 1 minute for you. Come on, this is the last question for today. Send me your answer through WhatsApp. Hope everyone give me the correct answer. First, you need to decide which formula to use. Is it IP over A, I proportional to A squared, or I proportional inversely proportional to 1 over R squared, or A squared proportional to 1 over R squared? Which one to be used? You have to decide first. If you decide wrong, then gone. Okay, I'm receiving answer. Receiving answer B, boy, root 2A. The others getting the same answer? I only received one answer. Oh, sorry, B. Yeah, receiving B. Or two of you giving B. So all of you getting B? Oh, yeah. So, yeah, many giving B. All of you giving B. Good. I'm getting the same answer. That's important. Okay. So which formula to be used? Which formula to be used? Okay. So the formula to be used is what? You use because this is about amplitude. So amplitude square proportional to 1 over R squared must come to your mind. So it's A proportional to 1 over R to be used. Okay. So A1 R1 equals to A2 over R2. They say the amplitude is A for the sound wave. The meter records intensity I, that correspond to amplitude A, the sound. At another position, the meter give intensity is 2I. Or I and 2I. The A. What is the corresponding sound amplitude? Oh, sorry. This is not about. Sorry, I made a mistake. Not A with R. This is I with A, right? Because I, when the amplitude is A, they're asking 2I, what is the new amplitude? What is the new amplitude? Okay. So this is I proportional to A squared to be used. So I1 over A1 squared equals to I2 over A2 squared. This is what to be used. So I1 is what? I1 is I, A1 is A squared equals to I2 is 2I. The new X we are looking for, X squared. X squared. Yeah, this is how you write. So X equals to what? X squared equals to 2A squared. Yeah, so X you get root 2A. S got B. Those who got B is good. Yeah, so root 2A. The formula must come to your mind is I proportional to A squared. Because nothing to do with the distance. They said I, A. 2I, how many A? So it's with the I and A. So I proportional to A squared. Okay, any questions so far? Okay, good. So far today's class you learn is what? You learn about intensity. What is intensity? Power over area of a wave. It's proportional to amplitude squared, inversely proportional to the square of the distance. Okay, so good. Any questions today's lesson? Okay, so if you don't have questions, we're going to continue with Doppler effect next class. We're going to continue with the Doppler effect next class. Okay, class. Okay, see you then tomorrow. Bye.